Hey there, this is checkpoint 2.51. They want us to find the distance between two parallel planes. Let's draw a couple of parallel planes. Say they kind of look like this. And they're parallel, they don't intersect, which means they have to have some sort of distance between them. And the other thing that we can assume is that, we can just grab a point from one of the planes and then find the distance between that point and the other plane. And if you remember the distance formula between a point and a plane, it requires projection onto a normal if you don't remember the formula. Anyways, let's assign the planes themselves. Let's say the first one is that plane, let's write it right above, 5x minus 2y plus z is equal to 6. And then the other plane would be 5x minus 2y plus z is equal to -3. So we have a couple planes. What's interesting is that so we can assume that they both have the same normal, and we can see that by looking at the normal vector. This one has a coefficient of 5, -2, and 1. And this one also has a coefficient of 5, -2, and 1. So if they're not exactly the same, they should at least be scalar multiples of each other. And that's our normal vector. And then the other idea is that if we dot this normal with a point on the first plane, we should get 6. And if we dot it with any point on the second plane, we should get -3. Okay. All right, let's find a point on this plane, and the way we're going to find a point is to just set two of the variables equal to whatever we want, and then we solve for the third variable. And so I think the easiest thing to do is let's let x equal to 0 and let y equal to 0 as well, and then we're going to get z is equal to 6. So we have the point 0, 0, 6 as a point on that plane. Okay, so now that we have the point 0, 0, 6, we just find the distance between that point and the plane. Okay, let's use a distance formula for that. Let's use and the distance formula tells us that we're going to dot this, let's say distance, we're going to dot this with the normal vector, so it'll be 5 times 0 plus -2 times 0 plus 1 times 6. Again, the dot product should equal to 6 because of this. That's not a coincidence. Minus, and then this is the plane that we're looking at, -3, and we want to, it's a difference, and so there's going to be 6 minus 3. Again, it's no coincidence that that's the d for this and the d for that, so we really can't come up with a different formula for the distance between two planes. Okay, and the denominator is going to be the magnitude of n, which is square root of 5 squared plus 2 squared plus 1. So that's 25 plus 4 is 29 plus 1 is 30. And the numerator is 6 minus -3, so that's 9. And it's absolute value, but it's positive already, square root of 30. Okay. All right, so that should be your result. Again, let's recap a formula here for the distance between two planes. distance between two parallel planes, and that distance can be found by let's write the equation of the planes down. Ax plus by plus cz is equal to let's call it d1, and it'll have the same normal vector, and so if we scale it to be exactly the same, they have the same a, b, and c, but now you have d2, and so the distance is going to be distance is going to be given by the magnitude of d1 minus d2, or the absolute value, the difference between those d1s, d2s, and then a squared plus b squared plus c squared. Okay? All right. I hope that helps.